Welcome to this video. In this video, I will describe and explain some performance measurements metrics for a specific application. I think it's about tracking aeroplanes on the sky. So how you will let's say you're tracking them, you're finding their path, probably doing some estimation as well. So in real life, yeah, for sure, there will be some algorithms for that, or you wrote a simulation software. How will you measure the uh, performance of your algorithm or of your software or of your simulation or in the simulation? Okay, so yeah, just I'm repeating. So what we want to do? We want to, yeah, I think it's about describing some performance measurement metrics for an aeroplane tracking application in the sky. And there will be some algorithm to track. And there will be, yeah, the aeroplanes are there. Or you can still have a target object in a simulation. And then there will be some sensors, say some sort of radars. Those are trying to measure the position of the targets, aeroplanes, and you have the software tracking algorithms. In real life, yeah, there will be some sort of software that is depending on the sensor measurements. They are trying to find out the path of the aeroplanes, one aeroplane or multiple aeroplane. So in this video, I think I will just describe say what are the different performance metrics and what do they mean. Yeah, that is the goal. So let's say, so if you want to define the performance metrics, you have to not perform. I think you want to measure the performance. You have to define some sort of metrics, some measurements. Measurements don't confuse with the sensor measurements. Some sort of criteria. Yeah, based on that, you can say, well, okay, your algorithm is working well or not. So you are successfully tracking, or you are not successfully tracking, or you are tracking with this degree of correctness or not, or yeah, how successful you are. So anyway, so before I go into that, I think you have to define some of the parameters that your performance will depend on. Let's say, so there are the targets, right? There are the targets and target actual positions and actual velocities. Those are the truths about the targets. Aeroplane current position, or the positions they are taking, or the velocities they are taking, and the path they are following. Those are the truth information. And there will be the radars. They are measuring the target positions, aeroplane positions, right? So those are your measurements, sensor measurements, we call it measures. And tracks, it's your understanding of the paths the aeroplanes are taking. Those you define as a tracks. So your sensory measuring, and depending on the measurements, you are finding or estimating the paths of the target aeroplanes. So those are defining as tracks. Now, how well you are finding the paths, estimating the paths or tracks. That's the performance measurements for your tracking algorithm or tracking for your software. Okay, that's one way. However, it does not always have to be that there has to be, you have to estimate the track. You can also define the performance measurements based on the sensor measures as well, right? So let's say there are the truths in your sensor measures, and how those measures reflect the target true positions, whether your measurements are close or far away. So that can be one set of performance metrics as well. It can be just performance measurements of the radars and sensors. How close are those measurements? What are the errors? What are the distance between the actual target truths, target positions, velocities, and your measured truths, measurement, positions, and velocities. The difference, yeah, not just plain difference. There will be some other ways of calculating. So that is one set of performance metrics, and there will be another set of performance metrics that will be the tracks, right? How successfully you are tracking those actual target paths. So those will be the tracks. Now, for this, I think to understand the true performance, you will need the true target positions, so that you can target positions to target a trajectory, so that you can compare your estimation and your tracks, compare with them, and then you will know the really what you are how your tracking algorithm software is performing. So in real life, for sure, when you are writing the software, and you can get this truth because airplanes, they will be recording their actual positions and actual velocities and actual trajectory. If you compare that with your tracking algorithms, so you can compare them and then measure the performance of your tracking. However, if the truths are not available, still you can do some sort of performance measurements of your tracks that probably will be consistency of your estimations and probabilistics. Okay, to my understanding, they will not give you the true performance metrics, but still you will get some ideas. I think it will also depend on the algorithms that you are using. If the algorithms are okay, let's say you have fine-tuned your sensors or radars so that they are very accurate, and your algorithm, they are very accurate, they were tested before. In that case, without the absence of true target positions, velocities, you should still be able to identify the uh, yeah, still you can get a good performance matrix. Okay, I'm making this up at this moment. I didn't study anything that says, okay, still that is possible or not. I didn't study anything on this. I'm just guessing that, okay, if the sensors are known to be giving real estimates within the field of vision or within the coverage region with minimal errors, and you know that the tracking algorithm that you are using, that is also very successful in lots of cases in real life scenarios. So under the circumstances, even without the truths, you can still estimate well. However, for the sensor measures and sensor tracking algorithm to reach to that level, my understanding is in the beginning of this development of these algorithms, tuning the sensor measures, you actually were required those truths. Otherwise, you are not supposed to come to this situation. Anyway, so okay, for now I will leave it here, and in the next video, I will go to the next step. So 334 to 342, yeah, it's almost close to 10 minutes. So T is the tracks, capital T is the tracks, capital L is the truths, capital M is the measures. In performance metric, these are the terms that will be used. However, you might see difference based on the papers, authors, countries, standards. Anyway, I do not know too much of it, but yeah, I know that that is the case. Anyway, so for now I am stopping, and next video